Hey folks, so in this video we're going to return to our review of Java syntax. So in the previous video we talked through an algorithm. We talked through this idea of linear search and basically how do I find an element in an array, and we spent the time basically to walk through a bunch of source code and figure out what was going on. So now we're going to kind of up the bar a little bit and do something a little bit more complicated. So what I want to talk about right now is this idea of a shape library. So this somehow is no longer has the flavor of a algorithm, which is what the previous example was about. Rather here we're talking more about data representation or data structures. So what I want to do is the following. This is my problem that I'm trying to solve. I want to have some way to define geometric shapes in a program. I have some examples over here: cone, sphere. These are things I want to represent. So what do I do? Well, what is it that I need to track? Well, for one thing, it's like if I want to represent geometric shapes, I'm going to kind of track different properties of these. So for example, looking at a cone, I probably need to track something like height. Okay, or looking at the base of it, maybe I need to track the radius. Okay, sphere, I'm going to need to track the radius. I'm going to have different pieces of data, different pieces of state. And even notice, that we have state that maybe is the same. So both of these have a radius. That's kind of interesting. Now, what about my program? Well, I would want to think a little bit about what is my program going to want to do with these shapes. Well, I'm going to have some common operations. I'm going to want to do things like, for example, find the volume of them or find the surface area of them. Those would be interesting things to do. So I have some thoughts here going on. What should I do? Well, let's break out classes. Okay, so in Java, I have this idea of a class, which is basically this encapsulation of both state and behavior. And what's kind of interesting here, well, there's a couple things that are interesting here. The first of all is maybe the observation that in my system, maybe I want to have many spheres. I want to have sphere A, B, C, D, and all of them look a little bit different. Hey, isn't that what classes are for? The idea of a class is I can say, okay, it's got kind of this blueprint to it, where there's some things associated with it, some state associated with it, and then I can have basically the ability to vary a state among different instances of that class. So because I want to have that, because I want to have a large sphere, a small sphere, an even larger one, maybe it makes sense to use a class. So that's kind of cool. That kind of solves the problem of multiple spheres, multiple cylinders, or multiple cones inside of a program. Here's another observation too. So we have, we said already we had basically radius, and those were kind of like the same. Okay. Well, maybe we can think about breaking out inheritance. Because remember, there's this idea in Java where we say, oh, hey, I have maybe a couple of different classes, and this one is like a parent of a child of a parent, And what that implies is that child has access to all the stuff that the parent has, So it's basically a way to borrow or reuse stuff from somebody else, which is kind of neat. All right. So let's move forward. Let's try and do this. Let's try and write some code to model this in a programming language. Now, in Java. Now, before we actually get to the code, though, I need to talk about something else, which is, of course, UML. So UML is Unified Modeling Language. Basically, what it is a way to model an object-based system. On the screen here, I have what is called a class diagram. A class diagram describes classes and the relationships between them. We can also read from them basically the state and behavior, or attributes and operations of the classes that are involved. So this is something you'll see several times, This is kind of a best practice, for modeling a system. It's a way to represent a program without having to deal with all this code. Because sometimes, you can imagine you have a program that has millions of lines of code. Do you really want to be scrolling through a million lines of code to go and figure out what's where or what functions are available? No, you don't. You want to have something like a diagram, You want to have something like a model representation that you can look at, quickly understand, and get a sense of how the system is put together and what sort of functionality is available. So let's take a look here. What we first did, was we have kind of this idea somehow of a parent class, So this is a parent class, and this is a child class. I'll give you guys those terminologies. Let's see. And I have a very, very specific type of diagramming, going on here. So I have kind of three regions to it. I have this region, and this region. I was not expecting the blue of my pen to be so close to the blue on the slides. It kind of blends in. All right, we have three different regions here. So we'll call this region 1, 2, 3. All right, so this is supposed to be a review for you guys. You should have seen this before. What is the contents of that first area there, the one that's marked 1? What is being shown there? What's being shown there is the name of the class. So first of all, we have basically round shape. We also have sphere and cone, So those are my names of my classes. Sphere is a child class of round shape. All right, what about number 2? What is going on in part 2 there, of that little rectangle which represents a class, my diagram? What is going on there? So that's where I have, well, I have variables, right? Or we call state, or what technically, right, in terms of UML notation is called attributes. Basically, it's, well, it's the way things look, right? It's the state of the class. So in this case, right, we only have one bit of state, which is the radius variable, okay? And you can kind of see that the notation here is maybe a little bit different than program code because the type of the variable comes after it, not before it. So we have, the name, radius, and then a colon, and then the type information. So it's a little bit different than what we're used to seeing in terms of program code. Also here what I have is basically this minus symbol. What does that minus symbol mean? That minus symbol is a visibility modifier. It actually is the same thing as writing the keyword public. Excuse me, the keyword private. If we had a plus symbol, it would be public. If we had a pound symbol, it would be protected. Here a minus though means it's private. So yeah, we got a radius. Let's see, back down to the bottom of the chart, area 3. What's going on in area 3? What am I listing there? Well, I'm listing methods, or I'm listing behaviors. So I have 4 different methods here. I have get radius, get set radius, get area, get volume. Okay, so that seems pretty good. Our notation here is again going to be the same, right? We have kind of the name of it. Now we have parentheses because it's an actual method, right? It's not just a variable. And the type at the very end. Let's see. Again, I got my parameters. So I have R, which is a double. Again, I have a special typing where it's like, well, the type occurs, after the variable name now, not before it. So yeah, I got four different methods inside this class. All right, so next thing is up. What about these? So there's 2 little arrows here, and these arrows look like basically a solid line and an arrowhead on the top. What do those mean? Those show an inheritance relationship. They show that my sphere is a child of parent, right? Sphere inherits from round shape. So this is basically how we denote relationships that are inheritance inside UML. There are also other arrows. So there's, well, like this one is basically to show 2 things are associated with one another. They're related in some way. Arrows can have, well, you can have all sorts of other things. You can have the diamond, which shows kind of a composition relationship. Filled-in diamond is another type of relationship as well. We have containment, composition. We have a bunch of different ones. When you get to more advanced classes, I'll go through all of them. For now, we just care about the inheritance one because that's a very typical thing. All right, so looking here, what's interesting, well, at least to me, is that my sphere class is completely empty. So I haven't added anything. But hey, maybe that's okay because the only thing I need for sphere is radius. And the parent already had a radius, I'm done. Oh, and what about the radius thing? Where did that even come from? Somehow there's the idea, right, when we do a design of a class-based system, that we're going to look at a bunch of different classes and we say, oh, hey, maybe I could have a parent for them. Let me see what sort of shared behavior, shared state they all have, and I'll take it and I'll move it upwards. I'll move it into the parent, right? It's the thing that like everybody has in common. So if I put in the parent, it'll only be in one place, and then by the Java inheritance rules, all the children will get access to it. Now, thinking about sphere and cone, the thing they had in common was radius. So here it made sense for us basically to put radius into the parent class. That way that both the children inherit that and they get access to that kind of, very easily. They don't have to write their own get or set radius, they just get it from the parent. So they're able to reuse that code, which is a very nice thing, right? It's going to save us time. All right, so let's look at the more problematic child. So I have over here cone. Cone is adding a new variable called height. It's a private double. Okay, and then I have 2 new methods, get and set height, because hey, I need access to that variable. So yeah. So that actually about does it for our diagram, right? So we have our 3 classes, there's an inheritance relationship. I have kind of 2 more specific things from the general idea of a round shape, right? So a round shape is a parent, it's a very general idea. I'm moving downwards, right, to a more specific idea, which is a sphere or a cone. All right, so that's about it for our diagram. Let's take a look at the code. All right, code's up on the screen. It's mostly parentheses. It's pretty straightforward. So I have here on my left-hand side my round shape. This is my parent. And maybe I'll add a little line here to maybe denote this a little bit better. So this is my parent class. And then I have, well, I just have one child here. I have the more interesting one. So what does round shape look like? Well, I have to have my private double radius, right? This is what we kind of already had in the diagram. We have, public class, because that's, we need to make this thing available and people can use it. The only thing kind of new here is the word abstract. What does the keyword abstract do? The keyword abstract is basically saying that this class is incomplete, that some of the functions have been filled out or some of the methods have been filled out, they've been coded, but then some of them are incomplete. And if I have a child later on, that child will need to fill those in. So that's what we have here, because some of the things, and that's what we need here, because some of the things, like for example, get and set radius, I can finish those right now. They're good to go. I don't need to do any other work. I can define them purely based on this variable called radius that I already created. And I even set up an instructor too. But then these other things like get area and get volume, well, I don't know enough about my geometrical shape to be able to compute those right now, right? I just have a radius. I don't know if I'm a sphere or a cone. I don't know enough. So those are basically going to be left as incomplete. And then when we get children, those children will be obligated to implement those, provide concrete code to calculate them. All right, so let's see. Okay, yeah, so this is actually a special type of method over here. Let's see, I may or may not, okay, I kind of spoiled it. We'll see if people remember. What type of method is this? What is this called? This is called the constructor. The purpose of a constructor is to build the object for the first time. Here, the work that needs to be done is basically just to set up radius. So it's relatively straightforward. Radius equal r, right? And r is a parameter we're bringing in. If we had a more kind of complicated, class, we would have other code here. But for now, that's all we need to set it up. All right. Next things, right, where those are just kind of simple methods. Or we've kind of already talked through that stuff a little bit in the previous video about how methods work in general. Get radius, set radius, they're pretty straightforward. And then we have the two abstracts, right? So these are things that kind of need to be filled in. All right. So this is basically my my parent class. So let's take a look at the child. So I'll start up at the top line. It looks a little bit different. Two differences here. First of all, we're removing the keyword abstract. That means that I have to fill in all my classes. I can't have anything incomplete. The other thing, though, is I've added the keyword extends. Extends is how we enable inheritance in Java. When I say that one class extends another class, that makes that a child of that other class. Right? It's the extends keyword. And there are several different keywords we can put here. Extends is one. Later on, we'll talk about interfaces, and there's another keyword called like implements, right, which does something a little bit different. For now, right, we just know that this is now a child of round shape. So what does the child do? The child has its own instance variable, right? So it has its own height, right? It can't put that on its own because that's what it needs to represent a cone. It's going to, of course, have the radius variable because the radius variable came from the parent, and while our inheritance thing is going on, that means we get everything from the parent. That radius is going to be there for us. We're going to be able to access it via the get radius and set radius methods that are provided by that parent. All right, so let's see. We got our constructor. Our constructor has some interesting stuff here. So notice it takes in two things, r and h. Fine. H gets stored into height. That's pretty much what we expect. But then we do this over here. We say super of r. What is that doing? So super is basically going to call the parent in the constructor. So super is going to call the constructor in the parent. Basically, it's saying that, oh, I'm inheriting from this class, so that class has a constructor. That means it knows how to set itself up. So let me go tell it, go set yourself up, right? Go do what the parent would have needed to set itself up, and then right after that line we have our high stuff because then the child can do whatever it wants, right? We need to make sure that the stuff we inherited from the parent, that stuff is probably set up first, right? We need to make sure we do that. All right. Moving along, get height, set height. Those are basically just get radius and set radius, right? It's same thing, straightforward. Over here, right, we have kind of some interesting things going on now. We have our get area and get volume, but unlike the parent, they're not just set as abstract, they're actually real methods. And because they're real methods, I have to write the code for them. So here, and the screen kind of cuts it off because it's only so big, but you can see it's like, get area, right? So you need, pi times radius times, the formula is there, right? Over here, the same thing for volume. I have pi times the power of the radius squared. All right, again, it's the code to calculate that particular value. So these, right, I'm basically obligated to fill in because the parent didn't have them, right? The parent did not have, any code here for volume, right? There's nothing here. So all of a sudden, child has to implement it. For something like get radius and set radius, those already had code. Those are coming from the parent. The child doesn't need to worry about them. The child can just use them. But the ones that are marked abstract, the child needs to fill in. All right, last thing is, of course, a toString, which is kind of a default method, which lets us say, if I want to print out the constants of the object, what should I display, right? So here it's basically set up so I can fancily print the area and the volume of the cylinder or the cone. So here it's set up to basically fancily print the area and volume of that cone. All right, so that about does it. There's a very quick walkthrough, right? Hopefully, right, you have a decent understanding, right, of the syntax and special keywords that are being used, in classes in Java, as well as how to read UML diagrams.